Hello everybody. Today we are discussing about viscosity, fluid mechanics. From this particular chapter at Eamcet level, we can expect one question as a minimum, and recently in recent years he has given two questions as well based on the same chapter. So what is viscosity? Viscosity, generally we take it as fluid friction. What exactly is going to be the fluid? The one which flows is called a fluid. In fact, all gases, they come under fluids, and of course all liquids also they come under the same fluids. So gases and liquids put together, we call them as fluids as such. The friction whatever we are finding when fluid layers are just moving from one place to the other, that actually is the main concept of viscosity. But when we talk about viscosity, when temperature increases, what happens to viscosity is a wonderful theoretical question here. For liquids, viscosity decreases, whereas for gases, viscosity increases. This is one of the theoretical questions one has to remember. And before taking up this particular topic, let me remind you few formulae what we people have taken up earlier while discussing about viscosity. The force of viscosity, that mainly depends on two factors. One of course is area, and one is what we call it as velocity gradient. Rate of change of velocity is called acceleration, but here this is change in velocity per unit length. That is what actually we call it as velocity gradient. So clubbing these two, F can be written as a constant into A into dV by dx we people used to write. But when you talk about this equation, this eta is called coefficient of viscosity. So how to write this value of eta now? The formula for eta is F by A by dV by dx. So this is one formula one should remember before taking up the problems on viscosity. Exactly in the same manner, there are other equations also in this chapter. One is Poiseuille's equation. Poiseuille's equation. What is this actually? The rate of volume flow of a liquid through a capillary tube of radius r and length L, that now can be written pi p r power 4 by 8 eta L. This is the formula. V here is called volume rate of flow. Volume per unit second or unit time, whatever that is flowing over there. And P is called pressure difference across the ends of the capillary tube. R is called radius of cross section of the capillary tube and L is length. But one thing more you should understand from this formula, P by V, when I write this one, it is 8 eta L by pi r power 4. Observe this concept carefully. Pressure difference divided by rate of volume flow of the fluid, we represent this one by R, which is called fluid resistance. Where we apply this formula? Whenever capillary tubes are connected in series, then we people used to say R effective is equal to R1 plus R2 plus R3 and so on, like in the case of electric resistances. Exactly in the same manner, when capillary tubes are connected in parallel, then 1 by R effective we people used to write as 1 by R1 plus 1 by R2 and so on and so forth. So this particular equation is going to be useful for you whenever capillary tubes are connected either in series or in parallel in any problem as such. So this is one zone one should concentrate on. Now come to the next equation over here, that all of us we know as the equation of continuity. A into V is constant. A is area of cross section. V is the velocity of that liquid which is coming out of that particular cross sectional area A. So in other words, you can say V is inversely proportional to A or you can even write it V is inversely proportional to square of the radius, because area of cross section we generally used to write it as pi r square, circular area of cross section there. So this is one point, and one should remember this equation of continuity is the direct application of law of conservation of mass, please remember that. In addition to that, when we talk about Stokes formula, that is what exactly is the viscous force that is acting on a body which is dropped into a fluid. We have a formula 6 pi eta r v. This v is called terminal velocity and r is called radius of that sphere which has been dropped into that particular fluid as such. So this is one more formula one has to remember before taking up the applications. Come to the next one over here. There is one more formula that of course we all know as Bernoulli's principle. What Bernoulli's principle says? The total energy of a fluid per unit mass or per unit volume that remains always constant across any cross section of the tube as such. Therefore, based on that particular point, pressure difference can now be written as half rho into V2 square minus V1 square. This actually is the equation ultimately what we used to get from that Bernoulli's equation as such. Coming to the next one, what is aerodynamic lift? That of course we write it either as pressure difference into area of cross section or half rho into V2 square minus V1 square into A. This is the equation what one has to remember. So in all these cases, this particular application you find directly from Bernoulli's principle. Bernoulli's principle is the direct law of conservation of energy. Remember that point carefully here. Likewise, Torricelli's theorem also we people have got in this particular topic. What Torricelli said is, whenever we people are finding a small orifice that is made and when water is taken till some height, say h like this, then through this orifice when water is coming out or jetting out like an efflux, then the velocity of this particular water is equal to like a freely falling body. That in the sense what? The surface of this water while coming down will feel as if it is a freely falling body like. That is the concept. This is going to be the velocity, and therefrom range can be written as u into under root 2h by g. This is the formula. U is nothing other than this velocity here. So remember these equations carefully before entering into the applications part of this chapter, viscosity as such. So let us take a few applications. As and when we come across a different concept there, I will explain you that concept then and there itself. So let us see the very first problem of this particular chapter, please. If the shearing stress between the horizontal layers of water in a river is 1.5 millinewton per meter square, and coefficient of viscosity of water is 10 power minus 3 Pascal second, then the velocity gradient in second inverse is how much? Just now I have told you eta is equal to F by A, that is the stress, by dV by dx. This is what is called as this velocity gradient. Now here the question is asked on velocity gradient. That means dV by dx is equal to this stress divided by the value of coefficient of viscosity. What is the value of stress that is given? 1.5 millinewton. That of course 10 power minus 3 Newton per meter square divided by what is the value of eta given? 10 power minus 3 again. So both they get cancelled and you are left with 1.5. One should remember that velocity gradient has got a unit equal to second inverse. So what will be the correct option for you now? The very first option is going to be the correct option for this first question as such. So 1.5 second inverse or per second, that's the value of this velocity gradient. Let us check the second problem in the same order, please. An artery in a person has been widened 1.5 times the original diameter. If the pressure difference across the artery is maintained constant, the blood flow through the artery will be increased by how many times? That is the concept. Just now I have given you that Poiseuille's equation. According to that equation, we know V is equal to pi p r power 4 by 8 eta L. That is the equation officially. Now blood flow through the artery means we just want V. V in turn is proportional to r to the power 4. So how to rewrite this equation now? V1 by V2 is equal to R1 by R2 whole power 4. That is the equation officially. But what has been given over here? R1 is as it is. R2 is 1.5 times the original diameter. Diameter and radius both are one and the same in one way because both are proportional to each other. So what will be R2 in this case? 1.5 means 3 by 2 times R1 whole power 4 we have to write. Now of course R1 gets cancelled. This now becomes 2 by 3 whole power 4. The 2 to the power 4 is 16 and 3 to the power 4 is 81. That is equal to V1 by V2. But our answer is, what is V2 the question? 81 by 16 times V1. This is the answer. That means how many times it increases is the question. When initial value is becoming V1, 81 by 16 times it is now going to be increased. That means you can understand for this second problem, the correct option is going to be the fourth one over here, which is 81 by 16 times as such. Let us check the next problem, that is problem number 3. Water is flowing through a capillary tube at a rate of 20 into 10 power minus 6 meter cube per second. If an identical tube is connected in series, the rate of flow of water would be how much? Identical tube, that means the length is same for the second tube. Even the radius of cross section also is going to be the same. One thing one should understand in this particular case, V and L are inversely proportional to each other. What for you people can understand once again, V is equal to pi p r power 4 by 8 eta L. That is the concept. So when you write V is inversely proportional to L, can't you just write V1 by V2 is equal to L2 by L1 please? Now you can certainly understand L2 in this case is 2L1 because both the tubes are of the same length, same area of cross section. Thereby L plus L now becomes 2L. If I take initial length as L1, the present length will be 2L1 over here, where L1 gets cancelled and you are left with 2 there. Then what is the question here? What is V2? It is V1 by 2. What is the value of V1 that is given over there? 20 into 10 to the power minus 6, that is the value, by 2. How much it will now be? 10 into 10 power minus 6 meter cube per second. That is the corresponding answer. So what is the corresponding answer according to the question number 3? That options are given to that. Third option is going to be the correct option for us. 10 into 10 power minus 6 meter cube per second. That's going to be the volume rate of flow across the entire system when two capillary tubes are connected in series as such. Let us check the next problem, that is problem number 4. A tank of height 5 meter is full of water. There is a hole of cross-sectional area 1 centimeter square at its bottom. The volume of water that will come out from this hole in 1 second is how much? One should understand volume of water coming out per unit second means, is it not rate of volume flow of the liquid again please? Rate of volume flow V can even be rewritten as A into small v also. A is called area of cross section of that particular orifice and V is going to be the velocity there. That is the point what you have to remember. Now what is the area that is given here? 1 centimeter square. Now you can write 10 power minus 4 meter square you can write. Fine. But what about velocity? Velocity actually is the velocity with which the free surface of that liquid that is coming down, because it has been given tank of height 5 meter is full of water. That means water level is going to be at a height of 5 meter. Then what will be V of a freely falling body? 2gh. Of course, G is given 10 in this problem. H is given 5. Therefore, this now becomes 10 meter per second. That is the velocity. Then what will be rate of volume flow? It is A into V. So 10 into 10 power minus 4. How much it will now be? 10 power minus 3 meter cube per second. Look at those options once again. The very first option that has been given over here is 10 power minus 3 meter cube per second as such. So for the fourth question, this is going to be the answer for us. But one should remember, V is equal to A into V. This is actually according to the concept of equation of continuity we people are discussing. Therefore, rate of volume flow even can be rewritten as area of cross section of the pipe into the velocity of that fluid which is coming out of that pipe as such. Let us check the very next problem, problem number 5 please. Water from a tap emerges vertically downwards with initial velocity 4 meter per second. The cross-sectional area is constant throughout the stream of water. The distance h vertically below the tap where the cross-sectional area of the stream becomes 2a by 3 is how much? In fact, you can all understand well, whenever we open a tap, then surely we find that water or anything is just falling like this, we feel. Now exactly in the same manner now also, when it is coming down like this, area of cross section is going to be increased. Then automatically the velocity is going to be decreased according to equation of continuity. Now in this particular case, here if I write A1 V1, here if I write A2 V2, these two are supposed to be equal according to this equation of continuity as such. So what is our equation now? A1 V1 is equal to A2 V2, fine. But what is area given in the beginning? Area of course he has given directly, it has 2a by 3 at the end, means initially a only, into with what velocity was it coming out? 4 meter per second, that has been very clearly mentioned over there. Is equal to what is the present area? It is no doubt 2a by 3, fine. But what will be V2? You should write this one, it is now coming down. In what sense? By h distance it is coming down. That is actually the concept. When it is coming down like that, what should be taken as velocity please? V square is equal to U square plus 2as. That is the formula we have to go for. Then what actually we have to consider here now? Look at this, V2 should be written as root of U square, that is 16, plus 2gh, 20 h like. This is the formula. That actually what is the formula I have used over there? V square is equal to U square plus 2gh formula I have taken up. G given 10, therefore 2 into 10, 20 into h. A gets cancelled, 2 cancels here twice, cross multiplication gives you 6. Now square it upon both sides. 36 is equal to 16 plus 20h. Now if you bring this 16 this side, 20h now becomes 20. Then what will be the value of height now? Exactly 1 meter. That means the distance h vertically below the tap, where the cross-sectional area of that particular system is becoming 2a by 3 is the question. So what is the corresponding answer over here? 1 meter. So which is the correct answer over there? The second option is going to be the correct option for this particular question number 5. So option 2, which is 1 meter, is the correct answer for that. Now let us check the very next number, that is question number 6 as such. A liquid flows through 2 capillary tubes A and B connected in series. The length and radius of B are twice that of A. Length is doubled and even that radius also is doubled. The ratio of pressure difference across A and across B is how much? That is the question. One should understand a simple point over here. Just in the beginning only I have told you, whenever tubes are connected in series, you should understand that like in the case of current electricity, when resistances are connected in series, that current remains constant. That is rate of flow of charge remains constant. Exactly in the same manner, when you are joining 2 or 3 these capillary tubes like that, when they are connected in series like, then what is going to be constant here? It is volume rate of flow remains constant. That means V is equal to pi P R power 4 by 8 eta L. When I take this one, V remains constant. Then what can I write now? P is proportional to L by R power 4. That is the equation. So I can now write PA by PB. It is LA by LB into RB by RA whole power 4. That is the equation one should write. Now here it is very clearly given that LB is twice LA. That is what has been mentioned there. Now what next? RB is also given twice RA. That of course twice RA you can write by RA whole to the power 4. Now of course LA gets cancelled, RA gets cancelled. 2 power 4 is 16 by 2 now is going to be 8. So what should be the correct ratio now? Either you can write 8 by 1 or 8:1. So what is the correct answer for us? The very first option is going to be the correct answer for this sixth question as such. One should remember from this question, whenever capillary tubes are connected in series, it is the value of rate of volume flow that is going to be constant across each and every tube like. That is a point. Now come to the next question, that is problem number 7. A large open tank has 2 holes in the wall. One is a square hole of side L at a depth y from the top, and the other is a circular hole of radius capital R at a depth 4y from the top. Both the distances are given from the top only. When the tank is completely filled with water, the quantities of water flowing out per second from the 2 holes are same. Then the value of R is how much? That is the concept. One should once again understand that there is a system like this. This is going to be the cylindrical tank. There is a hole here, there is a hole here. This is a circular hole, this is a square hole. This of course at a depth y, this of course at a depth 4y. This is what has been given. And water or this liquid is taken till the top, it is understood. Now what is the concept we people have to apply once again? He has given very clearly the quantities of water flowing out per second from both the holes are equal. Means what? V1 must be equal to V2. Volume rate of flow across the first hole, across the second hole, they are equal. That means what should we write? A1 V1 must be equal to A2 V2. Once again, equation of continuity is the result over here. Now if you look at A1, it is a square one. Therefore, L square is A1. What will be velocity now? Root 2gh. H is going to be y. That is actually the concept. Is equal to, what is A2 now? Pi r square. That is the area. What should be the velocity now? Root 2g into h means 4y. I should write now. That is the concept. So what you can cancel first of all in this particular case? Root 2 cancels, root g cancels, root 2 root g cancels, root y cancels. I am directly cancelling under root itself. One should understand this. Root 4 now becomes 2. So 2 pi r square you are finding there. Then what will be r square here? L square by 2 pi is going to be r square. What is r the question? If you take the root of that, L by root 2 pi, this must now be the value of r. Which one is having L by root 2 pi you see there? First option is going to be tallied with the same result. Thereby, you will be getting L by root 2 pi as the radius of that circular aperture what has been made over there. That is the orifice as such. That is the concept. So let us check the next number, that is question number 8 as such. 2 capillary tubes A and B are arranged in parallel. A liquid flows through these capillary tubes under the same pressure head. Both the tubes have the same length. The radii of A and B are r and r by 2 respectively. If the rate of flow of liquid through A is 8 centimeter cube per second, then the rate of flow through the combination of A and B is how much? That is the question. Now first and foremost, you should understand how the capillary tubes are being connected. They are connected in parallel. That is the point. When you talk about connected in parallel, go back to current electricity first. Similarity I am talking about. When resistances are connected in parallel there in current electricity chapter, we take potential difference remains constant. Here, this pressure difference is analogous to potential difference there. Therefore, here P across each tube should remain constant. That is the point one should understand straight away. So, what will be the formula? Pi P R per 4 by 8 eta L. If I take this formula, look at carefully, pi is a constant, forget. Now, both are connected in parallel means P also will be a constant, we can understand. Next, 8 anyhow is a number that is constant. Eta is constant coefficient of viscosity. In addition to that, length also is same. He gave length is same. That means what? V1 by V2 is equal to R1 by R2 whole power 4. That is the equation one should remember. What is this value of R2 here? This is R by 2 whole to the power 4. Now R gets cancelled. This now becomes 16. But look at carefully. What is V2? V1 by 16. What is V1 that is given over there? You look at once again, 8 centimeter cube per second by 16. Is it not half? Is it not 0.5 please? But wonderful question is asking you at the end. What is the rate of flow through the combination of A and B? Through A it is given 8. Through B it is given 0.5. Then what will be V? V1 plus V2. 8.5 centimeter cube per second. That is the answer. So what is the correct option there? Now you check it. Fourth option is going to be the correct option for this question number 8. Look at that one once again, 8.5 centimeter cube per second. This is question 8. Let us check the next number. Problem number 9 please. A pipe having an internal diameter D is connected to another pipe of same size. Same size means what? Length is same. Water flows into the second pipe through n holes, each of diameter small d. If the water in the first pipe has a speed v, the speed of water leaving the second pipe would be. Once again a direct application of equation of continuity. See that one, diameter d means A1 V1 is equal to A2 V2. What is A1 now? He is talking about internal diameter, that means circular. So pi into d by 2 whole square. Into what is the speed? Given v. What will be A2 now? It is n holes, n into pi into d by 2 whole square. Because d is the diameter that has been given. Into this velocity, if you take v, you take this one v1. Now pi gets cancelled. First thing, you can write d square by 4v, n into d square by 4 v1. Now you can cut 4. What is the value of v1? d square v by n d square. Check this equation now. V1 is equal to d square v by n d square. Which option that is coinciding? First option is coinciding perfectly with this. So this is the answer for this question number 9 as such. Okay. Now come to the next number, that is question number 10. An incompressible liquid flows through a horizontal tube A, B, C as shown. Then velocity v at the liquid through the tube C is how much? Just look at those values carefully. First of all, it is just given this way. There is one more tube this way. There is one more tube this way. And of course, it is mentioned over here. The area over here is going to be 2A. That's 1. And what is the speed of this particular liquid entering? 4 meter per second it's given. Now the area over here is given A. And what is the velocity with which the water is coming out is the question. This is A part of the tube. This is B part of the tube. This is C part of the tube. What is the velocity here when the area of cross section of this one is A is the question. What is the other area that has been given over here, please? If you just look at that one, area is A by 2. And with what velocity was it coming out? Again 4 meter per second is the velocity with which it is coming out. So what we should understand, this is a direct application of this equation of continuity once again. Whatever you can understand, A into V must be equal to A1 V1 plus A2 V2. Whatever the flow of liquid per unit second we are getting, same of course should enter into these two parts as well. So what can we write? A is given 2A, V is given 4, fine. What about this one? A is given A by 2 and velocity is given 4. What about this area? A into V2, the question. Now first thing you can do is A you can cut it off throughout. What is now left over? This goes twice. So this is 8 minus 2 is equal to V2. So what should be the value of V2 now? Simply 6 meter per second. This is actually the concept one has to remember. So what is 6 meter per second means which value that is tallying there? The fourth option is going to be tallied over there as 6 meter per second. So this is one more direct application of this concept called equation of continuity as such. Right? Now let us check the next problem. Problem number 11. This is completely based on Torricelli's concept. One of the very important models what we have, and the same model question earlier also in different papers of Eamcet we people have got them. So look at first of all what are the values given. A large tank with water to a height h is to be emptied through a small hole at the bottom. Fine. The ratio of times taken for the level of water to fall from h to h by 2 and from h by 2 to 0. So firstly h to h by 2, then h by 2 to 0. What exactly one has to remember for this model? Look at carefully first. There is a cylindrical vessel of which the area of cross section of the vessel is given as A small orifice that has been made here, a hole, its area of cross section is given as small a. Then what exactly is the way this liquid that comes out of it? If I have taken the liquid till the top, when liquid is coming out in the form of an efflux, then what exactly is the time taken by this liquid to come out of this system? That of course we have to remember A by A root 2 by G into root of H1 minus root of H2. This is the formula. Don't once again think it's some sort of a new equation like. This equation is a direct concept of a freely falling body. Look at carefully. Time taken, is it not root 2H by G formula officially for a freely falling body? But only thing is, this time taken will be more if area of cross section of the cylinder is more. This time taken is going to be less when this area is more. So that means what? T is directly proportional to capital A and inversely proportional to small a. That is the concept one has to remember. Now here his question is, what is T1 by T2? Ratio. Ratio means these two they get cancelled. So root H minus root H by 2. H2 H by 2, first of all it should be emptied. Divided by root H by 2 minus 0. Why 0 means completely when the liquid has gone out. What is the level of that liquid please? It is 0. This ratio we people have to take. Take root H common please. 1 minus 1 by root 2 by root H if you take common 1 by root 2 you will get. Root h gets cancelled. What is now left over? Root 2 minus 1 by root 2 whole divided by 1 by root 2. These two they get cancelled. What is now left over? Root 2 minus 1. So root 2 minus 1, the option is just tallied with the third one. You look at carefully. So third option is going to be correct. But one very important clue here I just want to mention. Suppose if that fellow says the water has come down by h by 4. Then height should not be taken as h by 4, please. You should take the remaining height, that is 3h by 4, to be taken up. So height always will be measured from the bottom. Remember that. If it is a depth, you can take from the top. That is the main concept one has to remember from this particular model, question number 11. Let us check the next problem, that is problem number 12 as such. A spherical ball of radius capital R, density rho, released into a liquid of density rho by 2, attains a terminal velocity v. Another ball of radius 2r and density 1.5 rho is released into the same liquid. Its terminal velocity would be how much? That is the concept. In fact, you all can directly understand. He has just given you, you see the points carefully. Rho the density of the ball first, 1.5 rho at a later stage. Rho by 2 the density of the liquid into which both the balls are being dropped. Then what will be the formula for terminal velocity? 2 by 9 into r square into rho minus sigma into g by the value of eta. That is actual formula for terminal velocity. What is what out of it? Try to understand. R is the radius of that body which has been dropped. Rho is for the density of the solid and sigma is density of the liquid. Now you can understand terminal velocity is proportional to r square into rho minus sigma now according to this equation. Let us take the same equation in terms of a ratio. It is r1 square by r2 square into what is this rho minus sigma for the first body divided by rho minus sigma for the second body, like we have to take. What are the values given? You look at. Radius is earlier r, now it is going to be 2r. So r by 2r whole square, fine. What is the density of the solid initially? It is given rho minus rho by 2 the density of the liquid, fine. What is the present density of the second body, please? 1.5 times rho. So 1.5 times rho minus rho by 2, you can directly write. Now r getting cancelled, you are left with 1 by 4 over here. Rho minus rho by 2 is again rho by 2, fine. 1.5 rho means, is it not 3 by 2 times rho, please? 3 rho by 2 minus rho by 2, it is 2 rho by 2. Directly I can write 2 rho by 2. This rho by 2 cancels, 1 will be left in the numerator. So 1 by 4 times 2, that is now going to be 8. Now cross multiply this one. V2 will now be equal to 8V1. That is the corresponding value. Earlier the velocity has been given as V. Therefore, you can even write this one as 8V also. So which is the correct option for this question number 12, please? The fourth option is the correct option, which now is going to be 8 times VSH. Remember this equation thoroughly and this relation for terminal velocity with radius and densities of the solid as well as the liquid into which that solid has been dropped. Let us check the next problem, problem number 13. A wooden cube of side 20 centimeter is found floating on a liquid with 5 centimeter on its vertical side above the surface of the liquid. If the density of the liquid is 0.8 gram per cc, then the mass of the cube is how much? One should directly understand what is mass of the cube means. Mass is equal to V into rho. What is this V now? It is nothing other than volume. Into rho, that is going to be density. What is the value? What are the values he has given you? You see there. Volume is of a cube, actually L cube. Fine. But the point here is 15 centimeter is inside the thing and only 5 centimeter is outside it. Then what you should understand here, volume is length into breadth into that height into the value of rho. What is the rho value that is given over here? 0.8 gram per cc. That means 800 kg per meter cube you can write. And what is going to be this height here now to be taken up? 15 centimeter is to be taken. That means this is 20, this is 20, 20 into 20 into 15. You will be getting in centimeter cube, centimeter to the power 6. In fact, centimeter cube. Centimeter cube to be converted into meter cube. 10 power minus 6 meter cube. Just to substitute these values there. V into rho, then what will be the value of mass you will be getting directly? You will be getting it exactly 4.8 kg. Such a silly question, in fact, you have to understand. What for means the height whatever we have to consider is about that particular amount of that body which is dipped inside the liquid as such. 5 centimeter is outside means 15 centimeter is very much inside. That is the point you people have to understand for this question number 13. Option you see it is tallied with 4.8 means fourth option. That's going to be the correct option for us. Let us check the next number, that is problem number 14. A capillary tube is attached horizontally at a constant head arrangement. If the radius of the capillary tube is increased by 10%, the rate of flow of liquid changes by about how much? That is the concept. One thing you should understand, he is asking you to calculate what? Rate of flow. V is proportional to R power 4. But at Eamcet level, you can even guess things sometimes. For example, 10% if R is going up, then 4 times 10% will be the minimum rise of V. 4 times 10% means 40%. But of course, more than 5% means the variation will be more than 40. There is only one option as 46%. So definitely that should be the correct answer. But okay, let us check that one. Let us take the initial radius as 100. Write this equation. V is proportional to 100 to the power 4. Now, if it is increased by 10%, it now becomes 110 to the power 4, please. Then automatically you can write this increasement in volume rate of flow as x. V plus x we can take. Now simply take the ratio, please. V plus x by V, that means 1 plus x by V is equal to 121 into 121 by 100 into 100 I can write. Because 110 into 110 into 110 into like that 4 times, 100 into 100 into 100 like that 4 times, 0 you cancel, 11 11 121 into 121, 100 into 100, that is the concept. Then what will be the value of x by V, please? This 1 going there becoming minus 1, then this becomes 121 whole square minus 100 whole square by 100 square. I can write like this. Apply the concept of a square minus b square formula, please. A plus b into a minus b, 221 into 21 by 100 whole square or 100 into 100. Now x by v, how to read this one? Change in volume rate of flow by original volume rate of flow. This is what is called fractional volume rate of flow. Suppose if you want percentage, you should multiply this one by 100. Then if you just simplify this one, it will be just above 46%. So what will be the corresponding answer for you? 46%. What do you mean by that plus sign over there? These two are directly proportional to each other. Therefore, if R increases, V also increases correspondingly. That is the very meaning of that plus sign over there, please. So fourth option is going to be the correct option for us for 14th question. Look at the next problem, that is problem number 15. Air is streaming past a horizontal aeroplane wing such that its speed is 120 meter per second at the upper surface and 90 meter per second at the lower surface. If the wing is 10 meter long and 2 meter wide and density of air is 1.3 kg per meter cube, the gross lift on it will be. This lift whatever we people are calculating in this problem is also called as aerodynamic lift as such. So what is the formula for that? F is equal to, either you can write P1 minus P2 into A, change in pressure into area of cross section, or half rho into V2 square minus V1 square into A. What are these two velocities? Velocity above the wing and velocity below the wing. So you people can write half into, what is the density that has been mentioned over there? 1.3 into V2 square, it is 120 square minus 90 square into, what is length that is given? 10, breadth is given 2. Therefore, 10 into 2, 20 meter square will be the area. Now you can directly cancel this one 10 times, fine. 1.3 you take it as it is. Once again A plus B into A minus B, like you take 210 into 30 into 10, that means 300. Come on, simplify this one. Whatever the value in Newton you people are going to get will now be the corresponding option for you. The exact answer for this one you will be getting it as 8.19 into 10 to the power 4 Newton as such. This is the formula for aerodynamic lift, please. Remember, one of the very important concepts of this chapter, please. Let us take the next problem, problem number 16. When a capillary tube is connected to a pressure head VCC of water flows per second. If another tube of same length but half the radius is connected in parallel to the first one, the quantity of water flowing through them per second will be how much? That is the concept. Just now I have mentioned, whenever capillary tubes are connected directly in parallel, then what you should understand, there in electricity, potential difference remains constant. Here, pressure difference that remains constant. When pressure difference is remaining constant, pi p r power 4 by 8 eta L, that is actual formula for the initial volume, that is V I take. What will be V1 now? Pi p as it is I write. R is now becoming how much? Same length but half the radius. So it is R power 4 by 16 into 8 eta L I can write. But all of you can understand pi p r power 4 by 8 eta L is V. Therefore, I can write this one as V by 16. Now, what is the question that is asked? What is resultant V is the question. V plus V1. That is V plus V by 16. That is 17 V by 16. That will now be your answer. So, what is 17 V by 16? CC. So, which option that is tallied once again? The fourth option that's going to be tallied here. 17 V by 16 CC. That is for the question number 16 as such. Let us check the next number. That is, water flows through a non-uniform tube of areas of cross section A, B and C, whose values are 25 centimeter square, 15 centimeter square and 35 centimeter square respectively. The ratio of velocities of water at the sections A, B and C will be areas and velocities. Definitely you should understand it is AV is constant. That is the formula to be taken. Equation of continuity. So V1 is to V2 is to V3. I now can write 1 by A1 is to 1 by A2 is to 1 by A3. In other words, I can write A2 A3 is to A1 A3 is to A1 A2. This is the way we people used to write this one mathematically. Now tell what are the values, please. A2 A3, it is 15 into 35 is to A1 A3, which is 25 is to 35, 25 into 35. What is A1 A2? 25 into 15. Now cancel 5 here thrice, here 5 times, here 5 times. Again you cancel 5 here, 5 here, 7 times here. 3 7 21 is to 35 is to 15. Further you cannot cancel anything there. So this must be the correct ratio. So what is the correct option there, please? The third option, which is the correct one, 21 is to 35 is to 15. That's going to be the third, the correct option for this 17th question. Look at that next one, that is problem number 18. In a horizontal pipeline of uniform cross section, pressure falls by 5 Pascal between 2 points separated by 1 kilometer. the change in the kinetic energy per kg of the oil flowing at these points is how much? Density of oil is given 800 kg per meter cube. Very cleverly he is asking. In fact, P1 minus P2 is equal to half rho into V2 square minus V1 square, that is the concept. So what can you write now in this particular case? In fact, half rho into V2 square minus V1 square means half into V2 square minus V1 square can be written as P1 minus P2 by rho as such. How do you read this one? Actually, half mv2 square minus half mv1 square means change in kinetic energy. Per unit mass means mass gets cancelled. This is the value what he is asking for. What is the change in pressure given? 5. What is the density that is mentioned? 800. So what is this value? 5 by 8 into 10 power minus 2. Then what will be your correct answer there? 6.25 into directly 10 to the power minus 3. What? You will be getting this one. Actually, it is supposed to be joule. Joule per mass. You can write joule per kg. This is the correct answer. That in the sense, first option is going to be the correct option for this question number 18. Look at the next number, that is problem number 19. A cylindrical tank of cross section 1 meter rests on a platform 5 meter high. Initially, the tank is filled with water to a height of 5 meter. A plug whose area is 10 power minus 4 meter square is removed from an orifice on the tank at the bottom. The initial speed with which water flows out. In fact, so many unnecessary values he has given in this problem. What ultimately is the question? What is velocity? Is it not under root 2gh for a freely falling body, please? 2 into g given 10, h is given 5, then what will be the velocity of that liquid coming out or oil coming out? It should be 10 meter per second. That means very first option that fellow is giving us for this one. That in the sense 10 meter per second is the correct velocity with which the liquid is coming out of the system. Look at the next number, that is problem number 20. When equal volumes of two liquids are mixed, the specific gravity of the mixture is 7 by 2. Equal volumes are mixed means rho 1 plus rho 2 by 2 is given 7 by 2. Next, what he is talking? When equal masses of the same two liquids are mixed, the specific gravity is 12 by 7. 2 times rho 1 rho 2 by rho 1 plus rho 2, that is given as 12 by 7. These are the values given. In fact, at Eamcet level, if you look at the options also, you can identify what is the correct option here. 2 getting cancelled, rho 1 plus rho 2 now will be 7. It should be. See the options carefully. 1 and 6. 1 plus 6 is 7. 2 plus 6 is 8. 2 plus 4 is 6. 3 plus 6 is 9. So 1 plus 6 must be 7. There is no need for you to calculate it further. So first option itself is going to be the correct option for this one. Otherwise also you can solve these two. Then also you will be getting 1 and 6. There is no doubt about that. Now look at the next number, please. That is question number 21. An aeroplane of mass 3 into 10 power 4 kg and total wing area 120 meter square is in a level flight at some height. The difference in pressure between the upper and lower surfaces of its wings in kilopascal. Very simple concept. Pressure is nothing other than force per unit area. That is the formula for us. Force in this case is mg by a. What is mass of that particular aeroplane given? 3 into 10 power 4. And what is the value of g given? Again 10. Fine. By what will be the area? 120. This 0 you can cancel. 3 cancels here 4 times. 1 by 4 means 0.25 into 10 power 4. This is actual value. Newton, this per meter square you can write like this. But see the options and adjust this one, please. It is how much he is asking you in kilopascal. Kilopascal means what? 0.25 into 10 kilopascal. We can write this way. That is the concept. Because 10 cube is called kilo. Now if you multiply this one by 10, 2.5 kilopascal will now be the corresponding value for this particular question. That means 2.5 is coinciding with the very first option for us in this particular concept, please. So these are the things what we people have taken up. And in addition to this one should remember this chapter thoroughly, because it fetches you one question as a minimum, 1 mark as a minimum, and at times he is giving even 2 questions also based on the same. Right. Next time whenever we shall meet, we shall take up the topics from heat and thermodynamics concepts of physics as such, please.